Okay, so we just started a little bit yesterday. We didn't really get into anything too heavy. It was just the idea, probability model, what a sample space is. How do we know that that's the sample space? Because everything, all the probabilities equal one whole. Okay, and then uh, these numbers in yellow are called random variables. Random variables are just all the possible outcomes. Okay. And then we talked about discrete random variables are a countable number of possible values. So if you can count all of the possibilities, it's discrete. So this would be discrete since there's only 6 things that could happen. You can count that. So it's discrete. Okay. Most of the ones we look at this chapter will be discrete. Every probability has to be between 0 and 1, including 0 and 1. And they all have to add up to be 1. If you add up everything, if there's something missing, it's not the sample space because there's something missing out there. Okay, so then we stopped with this one here. Okay, um, so how many languages? So they took of all the students, 63% of all students speak one language. 29.5% of students, U.S. high school students, speak 2 languages. 6.5% speak 3 languages. Less than 1% speak 4, and even less than that, speak 5 languages. Okay, that's the table there. So we talked about these guys are the languages, the number of languages spoken are the random variables. Okay, and then we stopped right there. So what we're going to do first is we are going to find what's called the mean. The mean, we've done the mean tons of times before. What's another word for mean? Average, right? Average. So what the mean is going to tell us is if I randomly picked a high school student, US high school student, how many languages would I expect them to know how to speak? So looking at the numbers, if you randomly picked the high school students out of the millions of high school students that are out there right now, you randomly picked one. How many languages would you expect them to speak? Probably close to 1, right? If not 1, pretty close to 1. Yeah. Why, Josh? Why 1? You're right. Well,
because 63% of the population speaks one.
yeah, it's a high bar, right? And then 2 is about half of that, a little less than half of that, and then it just drops off from there, right? So the best chance is 1, right? We would expect that, right? Well, that's what we're gonna do right now is we're gonna calculate the average. Okay. So to calculate the average, this is what we do here. To calculate the average, you see a lot of symbols here, but all of these symbols mean something. Okay. So the first thing here, so let's go through one by one. That's our symbol for mean, right? That's our symbol for mean. So the average of all of the random variables, x's are the random variables, right? Okay, that's what that means. Then you have equals e to the x. E of x is expected value. Okay, you're going to see that a lot this chapter. Expected value. Right? Because when I say, what do I expect to see? It's kind of asking what the average is, right? That's what you expect to see, right? Then we have this, it's a Greek letter, it's sigma. It's the Greek capital letter sigma. Anytime you see that in math, does anyone know what that means? Anytime you see this in math, what is it going to be? It's a summation notation. It means you're going to add. You're going to be adding things up. That's all that means. If you see it in math class, all it means is you're going to be adding some things up. So what are we adding? Right here, you see a bunch of things that get added here. X1 is the first random variable. I'm going to be multiplying that times the probability of that first random variable. And then I'm going to do it again, except with the second random variable. I'm going to be multiplying it with that probability. And I'm going to keep doing that until I get to the end, until I have no more random variables and no more probabilities to multiply together. Okay? So this is what it's going to look like. So let's find the mean of the list right above. So expected value. So the first thing we have to do, we don't have to write the sigma or anything like that. We're just going to calculate these numbers. Okay. So what was the first random variable in that list? 1, right? 1 language, right? So we're going to take 1 and we're going to multiply it times the probability of 1. What was the probability of 1? So we're going to multiply it times 0.63 plus the second random variable. What was the second random variable? 2. What was the probability of 2? Okay. And we're going to keep doing that until we run out of random variables. So 3 was 0.065. And then 4 was 0.008. And then the last one was 5, which was 0.002. That's it. Multiply and add. Okay, so I find the mean is 1.457. 1.457, right? So that's the average number of languages spoken by US high school students. So another way of saying it is I would expect a randomly picked high school student to be able to speak 1.457 languages. Now, that doesn't really make too much sense because you either speak a language or you don't speak a language, right? You're either fluent in it and you can communicate or you can't do it. So, in practical sense, I would say between 1 and 2 languages. If I were to randomly pick a high school student, in practically speaking, in English, like just in plain English, I would say they would be able to speak. Oops. They would be able to speak 1 to 2 languages. Yeah. Now, if I'm looking for the mean is 1.457, even though it doesn't really make sense in terms of in context. It doesn't really have any, right? Give me 1 second to get my picture back up here. Okay. Okay, so that's what that means. Now, with mean comes standard deviation and variance. Variance we rarely calculate, but it's really easy if you have standard deviation. Okay? So standard deviation, focus on standard deviation here. Standard deviation, again, we have that sigma letter again. We still have that sigma. Means we're going to be adding some things up, right? What are we adding up? Well, x is the random variable. This is a symbol for average. So it looks like we're going to be subtracting the random variable minus the average. Then it looks like we're going to be squaring that answer. And then it looks like we're going to be multiplying times the probability at that random variable. Okay. And then find the square root of all of them. Okay, so here we go. This is how you do it. Okay. So the first random variable was 1, right? So we have 1 minus, what was the mean we just found?
1.457.
Squared times the probability of 1. Good. Plus, so that's the first thing, plus, and we're going to keep doing that for all of them. So 2 minus 1.457 squared times 295 plus 3 minus 1.457 squared 0.065 plus 4 minus 1.457 squared times 0.008. And then the last one is 5 minus 1.457 squared times 0.002. And then after we get that answer, we're going to square root it. Okay, so we got to subtract, square, multiply, subtract, square, multiply, subtract, square, multiply, subtract, square, multiply. Okay, so when we subtract, square, 1 minus 1.457 squared is going to make it positive times 0.63. I get 0.32, 1.32. 2 minus 1.457 squared times 0.295. I get 0.087. 3 minus 1.457 squared times 0.065. I get 0.155. 4 minus 1.457 squared times 0.008. And then the last one, 5 minus 1.457 squared to 5. So I'm going to add all of those guys together and then find the square root. Okay. Okay, I get 0.451. And then I take the square root of that, and I get 0.672. 0.672. Okay, so let's go back. Let's go back a few. We haven't talked about this in 2 or 3 chapters. What does standard deviation, how do I put that in? How do I interpret that number? So how do I interpret? How do I interpret? No, not there. There you go. So let me switch these first. Give me 1 second. How do you switch that? Okay, never mind. Okay, so point, because this is one of the questions they're going to ask quite a bit. What happened? What happened here? Okay, so they're going to ask you to interpret that. Okay, so on average, the average student will be able to speak 1.457 languages. That number will vary by 0.672. By 0.672. Okay, that's what that means. It varies by almost half a language. So they could speak up to 2 languages or as low as 1 language. Makes sense. Okay. So again, to calculate mean and standard deviation, did I need a fancy calculator? Could you have used your phone calculator to do all of this? Yeah. Okay. Well, I'll show you how to do it a little quicker way. So take it now, use your calculators. Now bust out your calculators. Okay. So you're going to go to L1. Going to go to L1 and get rid of anything you have in L1. Get rid of anything you have in listwise. All right. So you're going to go to L1. We haven't done this for a while, but it's the same as back when we did it. If you have anything in L1 or L2, get rid of the list up to the top, hit clear, move down to the bottom, the list goes away. Don't hit delete or the list will go away completely. We just want to get rid of the numbers in the list. Okay, so L1. L1 is going to be our random variables. 1, 2, 3, 4, 5. Those are our random variables. Each of those mean a language spoken. L2 is going to be the probabilities that go with them. So the probability of 1 is 0.63. The probability of 2 is 0.295. The probability of 3 is 0.065. The probability of 4 is 0.008. And 0.002 for the last one. Okay, so pretty much we're just putting the table in there. Okay, now where do we go to find mean and standard deviation? Because that's what we wanted, right? We just found mean and standard deviation. Where do we go to find those? Which calculator functions do we do to do that? Not two variable stats. We don't use two variable stats. What did we always use? We use one variable. How do I get there, though? There you go. Yeah. Two variable stats we never use. I don't even know what that does because I've never used it. Okay, so we never use that. We only use one variable stats, even if we have even if we have two lists. Okay, so we go here. This is we're gonna do something we have never done before. List is an L1. L1 is your list of random variables. Frequency list we always skipped. We always skip frequency list, right? Well, now we have a frequency list. The frequency is the probabilities, right? That's in list 2. So this is the only time we're going to do anything for frequency list. This is the only time we're going to do it is in this chapter. Okay, because usually we don't have a frequency list. Usually we just have one list and that's it. But now we have a frequency list to go with it. So how frequent does 1 happen, 2 happen, 3 happen, 4 happen, right? Okay, calculate. Those numbers look familiar? Mean definitely does, and standard deviation, it's off by about 1,000th. We got 0.6672, they got 0.671. Okay, that's another way to do it. Okay, that's another way to do it. Like I said, but either way works. Either way works. So not so much in this class, but in past classes I've had, oh, I can't do the homework because I don't have a calculator. Well, you don't need a calculator. Or you just need a regular calculator, the one you have on your phone, right? You can just use that calculator and do some number crunching. It's going to take you about another 3 or 4 minutes, but you can still do it. 3 or 4 minutes is nothing. Okay. And you're not going to have a lot of these problems. You might have 1 or 2. Okay. So you'll be fine. You'll make it. All right. All right. Okay. So now what I want you to do is I want you to do one on your own. Here we go. We got a list of hot dogs sold at a minor league baseball team at a game. Number of hot dogs sold: 100, 200, 500, 1,000, 2,500. Probability for each. What's the probability that they would sell 100? 0.05. What's the probability of 1? 200. What's the probability of 500? 0.3. Okay, so be careful when you're doing these problems because I can already see some people falling into a pitfall. These are free response problems. Free response problems, how many points do you get for the right answer? 1 point. How many points do you get for the process? 3 or 2 or 4, however many more points, right? So a lot of you, what I see with a lot of just the right answer, move on. Yeah, that's not how AP math classes work. You have to show your process on how you got your number. They don't want naked numbers. Naked numbers are just numbers by themselves. I have no idea how they got there, right? So calculators you can use, absolutely. But I still want to see the calculation set up. You don't have to crunch the numbers, but I want you to tell me how you got those numbers. The worst thing in the world is someone grading your paper and they're like, how did they get those numbers? They have to ask that question, you're already going to lose points. Okay? So calculators are great, but I still want to know how you got those numbers. So set them up. I'll show you little shortcuts on how to set them up, but for right now, crunch those numbers. I'm going to show you a little shortcut, or shorthand, I should say. Not shortcut, shorthand. So expected value, right? I said you had to show where the number came from, right? You can use the calculator to calculate the numbers, but you had to show. So look what I did. I did the first 2. And then in the middle here, I put a plus dot 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 plus. That means you continue that process. You you say, okay, this is what I'm doing. In the first 2, you say, this is what I'm doing. And then you're like, I continue that process. And then you pick it up at the end. That's one way of shorthanding it. Okay, so that way you only have to write 3, and then you go to your calculator and find the answer. Okay, what was the answer for expected value? 1025. Hot dogs. Okay, so I'll show you how to do that for standard deviation. So from now on, you can do that shorthanded method. So standard deviation, we're going to do the first 2, ... plus ... the last one, and then we're going to go to our calculator. Okay, so the first one is, what was it? 100 minus 1025 squared times the probability of that, which is 0.05, right? That's the first one. Plus, and we're going to do it one more time just to let them know this is the pattern. This is the gist of what we're doing. Times that probability, which is 0.1, plus ... plus the last one. The last one would be 2,500 minus 1,025 squared times the probability of that under the square root. Now you can go to your calculators and you can figure out the rest. You can figure out the number. Especially long lists, this helps. You can do the whole thing if you want. You can list the whole thing out like we did in the first examples, or you can just do it this way. Okay, this is enough information to tell me where your number came from. So anyone have it? What is it? 793.02.
Yes.
Hot dogs.
Oh, you know, I just got that through standard deviation in general on the calculator. Oh, wait, I thought you were reading it for a second. I was like, wait.
No, that's the calculator, right? You got it from the tables? Oh, yeah. No, you're good. So that means if I were to go to a random game, there would be about 1,000 hot dogs sold that day. About 1,000 hot dogs sold that day. That number will vary by about 800 hot dogs. 800 more, 800 less. That's what that means. Okay. Okay, so now knowing this kind of setup here, I want you to do the one with sodas now. So do it from beginning to end. Sodas using exactly the methods I was showing you, or the shorthand that I was showing you. Do that one. I'll give you about 5. Okay, so 680 was the average. So let me put 680 in here. Okay. And then 476.025 were the standard deviation. So there's no question as to how these numbers got here. Even though I didn't write the middle, it's shorthand. You got the idea, you get the gist, right? The worst thing in the world is just for this question to see this. 680 sodas and that's it, right? I can give you 1 point for getting the right answer, but I can't give you the rest of the points because I have no idea how you got that number, right? So make sure you always are showing that's what I need to see on your homework, on your tests, on your quizzes, that kind of thing, okay? Whether you use your calculator, graphing calculator to do this, or whether you use a regular calculator to do it. To me, it doesn't matter because you're doing the same thing, okay? One's faster, obviously, but if you don't have access to one, don't worry about it. You can still do it using a regular calculator, okay? Okay, so let's see here. So